So now that we're aware of the categories of numbers, what is the best way to demonstrate these numbers or illustrate these numbers in a way where our human brains can kind of comprehend what we're looking at? And what they came up with is the number line, which I'm pretty sure you are familiar with. So the number line, it has tick marks on it, and these tick marks are usually at the integers. I mean, they don't really have to be, I suppose, but that's by convention where we put the tick marks. And then right in the middle, we're going to have 0. And of course, everything to the right is going to be a positive number. Everything to the left is going to be a negative number. 0 itself is neither positive nor negative. And this is kind of a sliding thing. If you go to the right, it goes off in infinite directions. And of course, you can go off to the left in infinite directions. And the number line is an invention. This is just something that mathematicians or humans came up with so our human brains can make sense of numbers, make sense of the world. And honestly, it's a pretty cool invention. It seems obvious now, but it wasn't always like this. It just seems obvious in retrospect. So props to you guys for inventing this in the past, whoever invented it. And keep in mind, the number line encompasses all real numbers. Do you remember the previous video? We talked about numbers nesting inside of numbers. And in the real numbers, you can divide them into two major categories, the rational numbers. So here are the rational numbers, but also the irrational numbers. Both of these are on the number line, both of these. And intuitively, we know that if we go all the way to the right and all the way to the left, it's going to go to positive infinity and negative infinity. What you might not realize is that even between two integers, for example, between -2 and -1, there's actually an infinite number of numbers between those two numbers. And it doesn't even have to be -2 and -1. It could be -1.5 and -1. There's still an infinite number of numbers between those two numbers. It's wild. And this was proven by Cantor's diagonal argument. The only reason I mention that is if anybody is interested in kind of diving more into that concept, you don't need to know it for the GMAT. But for me, I find math to be kind of fascinating. And if you do want to dive into these deeper topics, obviously the GMAT stuff is going to seem easier in retrospect or easier by comparison. So in that case, it's not exactly a waste of time. If you want to think about it that way, it's not exactly a waste of time. But of course, you don't have to dive into that. So don't worry about it too much. All right, so that's the number line. The last thing I'll mention is the way we read the number line is arbitrary. What I mean by that is whenever we look at a number line, we look at it as going from left to right. But it doesn't have to be that way. A number line on a graph or a chart goes vertically, right? I mean, we often see that. So just by convention, we tend to view the number line as left to right. But again, that was a decision that we made. It's not some natural law of the universe. As I said before, if we're looking at a bar chart, this is called the y-axis. This is called the x-axis. If that's not familiar to you, don't worry about it. We'll talk about it later. But in the y-axis, we're going to have this vertical number line. In fact, most languages are read left to right, right? Most languages are read left to right. But that's not true of every language. In fact, what's stopping us from having a number line that we read right to left? Some languages are like this. For example, Arabic is like this. Japanese in some forms is like this as well. So again, just keep in mind the number line is a convention that encompasses all real numbers. We read it from left to right. It goes to negative infinity to the left, positive infinity to the right. And yeah, that's the number line. Cool.